Hey there, class. Today I'm just going to do the review that I posted on Google Classroom. I'll check the YouTube later. If there's no views on this, what's the point of doing this? But if you do watch this later, then I'm happy to hear that. And I'll continue to do stuff like this. All right. So this is the review I posted today on Friday, 2/25. So you can check this out. I'm going to do all the work and then explain everything I'm doing. So these are the type of questions you'll get. Of course, it'll be formatted nicer for a test, but let's go through it. Write in exponential form. Now, we kind of talked about this in the later questions about solving, but if you have log base of 6, you could bring it to the other side and it becomes 36 equals 6 to the second power. So when I say write in exponential form, it should look like an exponent. So 6 to the second power. Now here we have evaluate. So we got to actually solve this. So log base 3 of 27. I don't have anything here, so I'll put a y in its place. So log base d of 27 equals y. Now the best thing I could do here is bring the 3 over, and then I have 27 equals 3 to the y power. Then I have to ask myself, you ask yourself in the deep of your soul, 3 to the y power gives me 27. What is the exponent that will give me 27? Well, 3 to the first gives me 3, so that's not it. 3 to the second gives me 9, well, that's not it. 3 to the third gives me 27. Wait a minute, 27 is my answer. So that means y equals 3, which means the evaluation for this is 3. Next one, evaluate 5 log base 5, 65. So I'm going to put an equal y here. Bring over the base of 5. So now it's 6 to 5 equals 5 to the y power. Then I ask myself the deepest of questions. 5 to what power gives me 625? So at 1, it's 5. No. At 2 is 25. No. And by the way, you don't have to do this in your head. Take a calculator. Use your advantages. 3 is 125. No. To the 4th power is 625. Hold up. Wait a minute. That must be right. So the exponent is 4. So 5 to the 4th power. 5 to the y power. So y equals 4. This one here, this should be a little bit easier. Log base 7 to the 7th power equals y. I'll do it in a different color so we don't get mixed up. So that's the same thing as I move my 7 over here. 7 equals 7 to the y power. This should be pretty obvious, but if it's 7 and this is 7, this must be to the 1 power because it's staying the same number. So y equals 1. You could pause the video if you need to copy that. Next part is the expansion. Expansion's weird because I don't think it's that difficult. A lot of people usually make mistakes, so let's avoid that. First one, log xyc. Well, they're all being multiplied to each other, and because you're really smart and you studied, you know that multiplication means they're adding when you separate it. So this is going to be log x plus log y plus log z. So log x plus log y plus log z. Because I separated and every piece has its side alone, we're good to go. Let's talk about the next one. Uh-oh, now we're dividing. But don't worry. When you divide, all that means is subtraction. So for number 5, you're going to get log x plus log y. Oh, I'm sorry, log z. And since y is in the denominator, you got to put a minus log y. So keep in mind, when you're multiplying, you add it. When you're dividing, you subtract it. Next one, log x squared y. Pay attention to this one. The square is only on the x. So if I were to split this, it'll be x squared plus log y. The square is only on the x, so only the x will a 2 move in front. So your final answer here is 2 log x plus log y. Okay, next one, kind of the reverse situation. You have log of just x, and you're going to have y squared. So you could just skip right to the final answer. Since you know it's going to be y squared, you could put 2 in the front because the exponent goes to the front, 2 log y. Next one, log xy to the second power. Notice how the second power is on everything. So you could do it 2 ways. I think I'm going to do the way that's easiest for you, which is let's move the 2 in front first. So I'm going to move the 2 in front first. So I'm going to have 2 log xy. Then I'm going to split the xy. So 2, when I split it, it has to be in parentheses because that 2 should be on everybody. So log x plus log y. So that is the parentheses. Now, if you were to distribute, so you have 2 log x plus 2 log y, 2 log y, you will still get the right answer. I want you to know these are both okay. Next one is a bit of a doozy. We have an awkward situation. It's square root xy. Mr. Tobel, you never told us what to do with square root. I did it, but I do know what we know how to do with an exponent. So you have to recall from last chapter, the square root is the same thing as saying xy to the half power. Once you see it as the half power, then you could do your exponent tricks, where you move this down over here. So it becomes 1/2 log xy. Then you could split it 1/2 log, I'll put a parenthesis, log x plus log y. So 1/2 log of x plus log y, and that is our function. Next one, it says simplify ln e to the 5. Now, if you don't have a calculator, well, you don't need a calculator for this one. Here's what's important. First off, everyone always asks me, how do we know how to do with e? Remember that ln equals log e. It is log e. Now, since we know it equals log e, that allows us to do something. Because it's log e, this is the same thing as saying log base e, normal e, 5. Now keep in mind, the opposite for the base of a log is the same as the opposite for the base of an exponent. Since this e is the base of a log, and this e is the base of an exponent, you are allowed to cross those off. Which means once you cross them off, all you have left over is 5. I'm going to say this. Maybe you look at that, you're like, well, Mr. Tobel, how does the exponent 5 become a normal 5? You could technically move it in the front first, then cross it off and reduce it to 1. So it's a normal 5. But however you think about it, I don't care. I just want that end result to be correct. Next one, E ln 7. I could rewrite that as E log base 7. I put a Z for some reason. Log base 7, or base, my gosh, log base E normal 7. My fault. Now, as I said earlier, the base of a log is opposite to the base of an exponent. That's true in reverse. The base of the exponent is the reverse of the base of the log, which means I could cancel these out, and what I'm left with is 7. So if your exponent base and the base of the log matches, you can cross it out. That's on purpose. The same way, if you multiply by 3 and you divide by 3, you could cross out the 3. If your base is 3 and your exponent base is 3, you could cross out the 3. All right. This question, usually I say condense, would be the instructions here. But write ln 12 plus ln 3 as a single log. So ln 12 plus ln 3. So you got to think in your brain, because you study really hard. You know that when you see a plus sign between two logs, that means you can multiply it. So this is ln 12 times 3. ln 12 times 3 is 36, because 12 times 3 is 36. Here, ln 45 minus ln 5, you study real hard and you practice the rules. So it's like Mr. Tobel tells you every time. So you know that it combined is going to be division. So 45 divided by 5, which is ln 9. Now, if you know any of your classmates are not studying for this test, tell them to study, because they're going to absolutely fail this test if they don't study. I'm going to have to pause this video and do a second part, because I forgot I have a faculty meeting. So I'll finish this later.